Good morning. Am I audible?
Yes, sir.
Let us start. It seems people have retired from the course. Okay, let us. Is the presentation visible?
Yes, sir.
Okay. So we have been doing a lot of processes and those kind of less interesting, apparently less interesting details. So I'll get back to some coding stuff and design related stuff again. I'll just give you a glimpse of what is design pattern. I mean, that's a based on object-oriented programming. The knowledge of design patterns significantly help in your design ability. Design patterns are described in a very nice phrase. They are recurring solutions to recurring problems. Right. So you must have experienced this somewhat already through a pattern which at least two patterns you have already used extensively, though we did not state them in the form of a pattern. One was a singleton, where a class can have only one instance, and you have seen through the assignments that how frequently such classes and such singleton objects occur. So what we have done is we have a one or more design options that we have discussed, and we can use any of those. What I mean, depending on your situation, there could be more options, of course. Depending on your situation, you can use it wherever you find that such a class is required. So the advantage is these solutions are canned. They have been used by thousands of others, have been scrutinized by the experts. So when you use such solutions, you know that what are the consequences, and you know that things would be, I mean, everything would be okay, and what are the risks involved. So singleton pattern is a recurring problem. Singleton is a recurring problem, and you have recurring solutions whether you use the kind of global pointer based solution or Myers singleton or anything of that sort. Similarly, you have also have used extensively another pattern, which is the iterator. With the STL containers, they have become very popular. So with the iterator, you can actually iterate on a collection, on an aggregate in a container, starting from a beginning to the end, incrementing at every point and accessing every element. And the most important thing is this iteration code does not change based on the internals of the container. So the way you iterate a list and the way you iterate a vector, or for that matter a map, are all the same. So you have a recurring problem which is iterating on a container, and of which you do not want to know details of the internals. The internals might change also, it does not matter. And you have a modeled solution which can be used for any one of this. So you have again a recurring solution. So that's kind of is the whole idea of design patterns. Before I get into the core of design pattern, I have a couple of minutes of fun stuff for you, which is really talking about patterns themselves in life. So this is what we will do is patterns occur everywhere. We'll talk about fundamentals, and we will talk about what is accepted as the kind of a gold standard in design pattern, the GOF pattern, the Gang of Four pattern. It is not standard in the sense of uh, you know uh, international standardization body, but it's kind of accepted very widely as a as great collection of solutions. So patterns happen everywhere. I mean, if we look at, they happen everywhere in life. So we have this kind of summer, winter, autumn, spring, and it's a climatic pattern. We have new moon, full moon. We have lunar pattern. We have patterns which are magnetic. So there are several kinds of patterns in nature. There are patterns in our daily life, like Vairavi, Malko, Shankswadhwani. These are musical patterns. We say ragas. We have poetic pattern in sonnet. We have patterns in Bollywood. Bibi number one, hero number one, Jodi number one, Premi number one. All different kinds of number ones became a pattern in Bollywood for a lot of time. You have patterns used typically in media, used with the plan. I mean, with a pun. So when Hesh won, it was called historic win. When the Narmada Dam was built, it was called the damned, and so on and so forth. You have grammatical patterns. So arts, humanities, everywhere you have patterns. I'm sure you will recognize this. This is a very typical pattern. You'll say there's a way the soccer is played by different coaches. Castling pattern is important in chess. There are different kinds of patterns in sport. There are patterns in crime, in politics, serial killers, terror attacks, dynastic patterns, so on and so forth. So these are patterns in housing, in cooking, in typesetting, everywhere. Wherever you look, there is a pattern that you can discover. And exploiting the power of those pattern. I'm coming closer to our subject. We have algebraic patterns. I don't know if you may not have done this algebras yet. Semi-group, monoid group, abelian group. You have programming pattern in terms of unconditional and conditional branch, definite loop, infinite, indefinite loop, recursion. We have algorithmic patterns. I'm sorry. We have design patterns, and that's what we are going to discuss. Before that, I will have a quick quiz. Can anybody tell me who is this person? He is known for this. Oh my God. Probably some of you saw it. Can you tell me who is this person? See, this sentence is very interesting, because here's a sentence which says this sentence is false. So if you take it as a truth value, then the sentence is false. So which means the sentence is not true. So if it is not true, then the sentence is not false. So if it is not false, then the sentence is true. So you have a circular logic here. And this person first brought this out. Can anyone say who is it?
So the pictures of Gödel were the sentences of Russell. I don't know if.
No, he actually built up the theory explaining this sentence. Yes, that's true. That's true. So this is Kurt Gödel. We have a very famous Gödel's theorems and all that, which have great impact in computer science. How about this person? Can you recognize? He's a champion of graphic patterns. He's a creator of this drawing. Anybody? You are not interested outside of mathematics and computer science. He's also creator of this. Yes?
Looked like the impressionist movement started.
What is his name?
You can Google it up.
So he's Escher. He's a Dutch graphic artist. And I mean, you can see, I mean, I picked them here because, yeah, this is, I mean, the kind of patterns he produced was amazing. I mean, the ultimate in recursion, so to say. From a different domain, any idea of who this person is?
No, this is Bach. Sorry.
Right. You all are quite. This is Sebastian Bach. So, okay, who is this? First, try to identify which field he is in from this clue.
Chess, probably.
Yes.
Emil
Chess.
Fisher. I can see Fisher in the
Yes.
Emil Fisher. That's Knut.
That's not.
Yeah. That's Fisher. And this somebody has just looking at the picture has said, who is he? So he is kind of our godfather, I should say. This is sorting networks created by him, Donald Knuth, the father of analysis of algorithms. I'm sure you will not know this person.
So Robert Floyd.
No. He's far, far away from common interest and our areas. His name is Christopher
Okay.
Alexander.
The guy who made the first pattern book.
Yes. So he is the person who first, he was an architect. And creating different architectural designs, he first realized that there needs to be a language for the patterns. And once that language is defined, then it becomes easier for people to understand, what is a good solution and what is not, and have that recurring solution. So that's where the story begins. So now we'll get back to what we want to do, that patterns are there everywhere. They drive research, and they're the greatest exploits for design. So when we come to the specific case of computation, there are different kinds of patterns we keep on saying. One is architectural pattern. This is a client server architecture. This is a 3-tier architecture. So you know the details will differ, but the overall solution structure is known, that you are creating a website. You'll ask that are we doing a 3-tier architecture, or are we doing a 2-tier architecture, and so on. Then there are design patterns, and then there are patterns in the code, which typically are called idioms. Right? So architectural patterns, we know this is different kinds of architecture. Several more would be there. I mean, I just tried to point out that design patterns are not unique by itself. Their patterns are there everywhere. So a design pattern suggests a scheme for structuring the classes in a design solution and defines the interactions that are required. Solutions are typically defined in terms of classes, instances, roles, collaborations. So the concept of a pattern, as I just said, came from Christopher Alexander. But in 1990, the Gang of Four, Gamma, Helm, Johnson, and Vlasidis, all four of them were working on the same idea. And then some other people suggested that why don't you collaborate? Instead of creating each one creating every own version of it. So they collaborated very strongly to create this prescription for the community, which became famous as Gang of Four, or GOF. Now, idioms are also kind of patterns, but they are far more low level. And most important thing is idioms are language specific. And they describe how to implement a solution to a particular problem using a given programming language. So this is kind of an idiom. Like in English, we have idioms like raining cats and dogs. Raining cats and dogs has nothing to do with cats or with dogs. It just means torrential rain. Similarly, here we have a pattern for a for loop. It's a C idiom that you'll always like it like this. So just to understand that pattern and idioms match in a certain way, because they provide kind of recurring solution. But design patterns give a recurring solutions which has just a core solution and is capable of generating many distinct designs. It's not that it's one design that you are having, like what the idiom usually will have. It has a much narrower context, and it's typically language specific. And we also have anti-patterns. Anti-patterns are kind of patterns which you should avoid, right? If at the end I get time, I'll talk about those. And also understand that patterns are different from algorithms. Algorithms primarily focus on solving problems with space, time, and other resource optimization. But patterns try to give you an overall I mean, in a design context, it gives you an approach of how to address that problem. So a design pattern describes a problem which occurs over and over again. All problems do not graduate to become design pattern. And it describes a solution which should be sufficiently generic, applicable in a wide variety of contexts, and often and usually should be codable in multiple languages, almost in every language. So that is how it becomes a recurring solution to a recurring problems. Now, a design pattern typically has to be described in terms of so if you open a documentation to learn about a design pattern, you will look for certain essential elements. First is the name of the pattern, which describes the pattern. Like we are saying, singleton, iterator, these are names. It states the problem, that is what to apply the pattern and its associated context. That is where the problem is. It describes elements of the solution. That is that makes up the design, their relationship, responsibilities, collaborations between elements, and so on. And it also must describe the consequences. What is the result? What is the trade-off in applying a pattern? For example, while we were discussing about singletons, or maybe in one of the clarification series on the assignment, we talked about that singleton pattern done with a global has a disadvantage in terms of initialization, because you do not know when it will get initialized. And if it happens to get used before that, then you have a problem. You also have the overhead of remembering to release it. When you have 20 singletons in your project, it will be really difficult to keep track that all of them has been released at an appropriate point. Whereas Myers singleton becomes easier in that way, because whenever you use it, it gets created. It's automatically destroyed because it's a local object, and so on and so forth. There are issues in terms of threading. So a global-based singleton solution will have issues with threading. So we'll have to keep all of these in mind in terms of the consequences that you put on. So example pattern, I have already said, it is an iterator. The problem is how to solve, say, serving the patients at a doctor's clinic, an example problem. The solution could be the front desk could manage the order of patients to be called. And that part of the solution is common. But what is specific that you can choose to implement is it could be by appointment. It could be FCFS, first come, first serve, order of arrival. It could be by, and at least in India, by extending gratitude. You give $20 to that man at the gate and jump 4 people in the queue. It could be by exception. I mean, you have taken someone who is very senior on wheelchair. So everybody would agree that. So the solution could be different. But the generic solution is you have to have an ordering for serving the patient so that you can have good patient satisfaction, the clinic's efficiency would improve, the doctor's productivity would be better, and so on. So as I said, every design pattern will be described in a specific format. Few essential components we have seen. So the iterator pattern, we will just see how iterator pattern is described. So we usually give 2 things. One is we say the name of the pattern, and we give its classification, what kind of pattern it is. Like your singleton is a structural pattern because it talks about a structure of the class, of the objects. Whereas iterator is a behavioral pattern because it talks about a behavior. And this is the intent. Intent is to provide a way to access the elements of an aggregate object or container sequentially, right, in some sequencing order, without exposing, this is very important, without exposing its underlying representation. Now, each one of these, the solution is such that each one of these can have variants. For example, a container could be any of these or any other, even it could be a tree. It's a, say, a breadth first traversal, a depth first traversal, an in order traversal, and so on, are all actually iterations, right? So even a nonlinear data structure, a nonlinear container, would be eligible for the iterator pattern as an aggregate object. Then what do you mean by sequentiality? You can define sequentiality in your terms. It could be forward sequencing, it could be reverse sequencing, it could be bidirectional sequencing, it could be random sequencing, and so on. So the pattern should cater to all of that. It should provide a way to access. Now that access could be read-only, and you have seen constant iterators for that. It could be write, it could be read-write, and so on and so forth. So what you see is this is the kind of way the intent of a pattern will be described. And then it's alias, typically known as AKA, also known as the iterator pattern is also known as cursor. The motivation as to why you want to do that. So you can, there's a aggregate object should have a way to access elements without exposing the internal structure is the first motivation. And there's a need to traverse the list in different ways. And multiple traversal may be pending on the same list. This is a very, very key thing, that it is not necessary if I have a list and if I make the iteration a feature of the list or a part of the list in the design, then at a time we'll only be able to have one iteration. But if I take iteration out as a separate component and keep the list independent of that, then I may have multiple iterations going on in the list at the same time, because the list object is not getting affected. So the key idea of this pattern is to take responsibility for access and traversal out of the list object and put it to an iterator object. So this is how we will model it. We have a list, and a list iterator has a will have an association with the list. Okay? So list has its own methods. List iterator has primarily, 4 methods: first of the list, next of the list, is done to know whether you are completed, and what is the current item. Like, this is the whole concept of iteration, right? And naturally it will have a private member to say what is the index, to remember where you are on the list. So if we look at in terms of generalization, then I have abstract list and iterator, so that the client can use both, connect both. The abstract list at its creator for the iterator and its other methods, and the iterator will have the 4 members. And then you can instantiate concrete lists and iterators. Like, so abstract list could have a concrete specialization of a list associated with a list iterator, or it could have a skip list. I do not know if you have done skip list data structure. It's a kind of a data structure where you can search in, if there are n elements, you can search them in square root of n time. So it in many contexts it becomes very efficient to do. So forget about those details. If you know, it's fine. If you don't, it does not matter for our context. So I could have a instantiation of a skip list with an instantiation of a skip list, specialization of a skip list iterator, so that the skip list will instantiate a skip list iterator, a list will instantiate a list iterator, right? So this is how it can generalize. Naturally, applicability you have understood. Whatever was motivation is the applicability of this. So this is how the structure will look like. You have an aggregate, which is abstract. You have an iterator, which is abstract, and you specialize to create a concrete aggregate, which implements the create iterator method, which creates the iterator. And concrete, so basically create iterator will instantiate, as you can see, it is doing a new on the concrete iterator given this aggregate. This is the aggregate. So the the concrete iterator needs to know the concrete aggregate, right? So it passes itself on, and then it has that iterator available which can be used. So these are the 4 participant classes, and that is how you specify them in the design pattern. There are collaborations. The concrete iterator keeps track of the current object in the aggregate and can compute the succeeding object in the traversal. So there is a kind of collaboration between them. And the consequences, it supports variations in the traversal. It simplifies the aggregate's interface. More than one traversal can be pending on the aggregate, and so on. Now, in terms of implementation, there are obviously several questions. For example, who controls the iteration? Is it external, or the aggregate itself in some cases control the iteration? Who defines the traversal algorithm? How robust is the iterator? For example, during iteration, if I insert an element in the list, will the iterator be able to take care of that, or it will have problems? If I delete an element, what will happen? There could be additional iterator operations. There could be polymorphic iterators, which are allocated dynamically by a factory method. I'll see if I get time to talk about that. Iterator may have privileged access and so on. Iterators for composite, null iterators, and so on. I will not get into all that. Now the code, here's some code. I will just very quickly run through it because you all have the concept. So I have a list, I have a count function, I have a get function. This is a list class templatized with item type. Then I have the iterator, what is happening? Class, which has the 4 methods as purely virtual. And it has a constructor which is protected. So it's specialization. If I have a list iterator from this iterator now for the item type item, then I can specify these 4 operations and can also have a constructor of it in the public. Now, naturally, in the private, I have a pointer to the list held, and I have a current marker to know where I am in the list. So the implementation of these functions are very straightforward. We'll skip over those. The constructor, the first, the next, the is done. Is done is when current equals the list count. And current item, obviously current item, if you are going past the iterator, which does not happen in STLs because it's all taken care of. But in general, if you do that, then if is done is true, then you cannot go to the next item. So you'll throw an iterator out of bounds error. Otherwise, you will get back the current item. Right? So with this, you can write this kind of a code, which we have seen that given that iterator, I can print all employees from a list of employees. So I have a list of employees, and I can print employees in that way. And I can have a forward list iterator. I can have a backward list iterator and print them in whatever order. I don't need to do anything in terms of the print code or in terms of the employee class. This whole, the separation of concern here is the most important, that the way I iterate is taken out of both the employee class, the list of the employees, as well as the print application that I'm doing. Right? So there are examples of iterators from the STL. This we have already used. So every container has an iterator type as well as a const iterator type, and it supports a begin and end, first, is done is replaced by having a marker beyond the aggregate, and this is the get. This is the next item, plus plus or prefix or postfix, whatever the next item. And IT, this iterated, is actually a pointer to the current item. So you can dereference it and get the current item. There's a solution with map. These all you have already known. So these are some of the other properties that are known. Use is iterative, is common in object-oriented systems. It's a composite. It has relation to composite pattern, factory method, memento, and all that. Forget all those. So this is the basic structure of the design pattern. Let's skip these details and let's go to examples again. Okay. So this was about the example of what you have, what a design pattern could be. This is kind of a representation of a set of design patterns from Gang of Four. This is not an exhaustive list, but very comprehensive yet. And in different domains, these are also, I must say that these design patterns are kind of generic in the sense that they are useful in almost every domain in which you design software. But there are several domain specific design patterns as well. So in certain specific domain, in graphics domain or in hardware domain, people have created design patterns based on the patterns that are frequent in the designs specific to that domain. Even some companies have their own design pattern based on their kind of unique solution or patented solution that they would use internally. So here in the generic, we have two dimensions in design patterns. One is the purpose of the design pattern. I mean, what does it want to do? So some patterns are creational because it talks about something which is related to the creation of or instantiation of objects. Some others are structural. So they talk about the structure of the classes. And some are behavioral. They talk about different behaviors. So what we have seen right now is iterator, which is a behavioral pattern. Is it talking about the iteration behavior? Singleton, I was loosely referring to as structural, but it actually is a creational pattern because it talks about the core issue of singleton is you cannot create more than one object of a class. So it has to do with creations. These are very important creational patterns, factory method and abstract factory, which talk about, could I have a mechanism by which I will give the name of a class and the class will get created or class will get instantiated and so on. There are patterns which are otherwise also important. For example, this facade pattern. Facade, is a front face of a building, right? And often the interior, often people make very beautiful facade because most of the people get to see the building from outside. So what they get is a very nice view. Inside, it may be a very different view. So often you want to present a different external view for a particular object. So you create a facade object. You could create a proxy object. Certain objects are required which you do not want to spare with. So what you do is you create kind of a proxy and give that object and get that task done. So there could be different kinds of such structural patterns. There are different behavioral patterns. The other one which actually came in our context in the assignment is a visitor, which is a pattern which is very important when you have a class hierarchy, and which kind of is usually static. Static in the sense does not change very often. but you want to add functionality to it in future without recompiling the code, right? How do you do that in a well organized manner? So visitor pattern talks about that. You have a command pattern, which is where I mentioned about this while we discussed functors, function objects. The command pattern is how you build a command and delegate it for execution. How can you do, separation between the creator of a command and the delegated executor of a command, or the receiver of the command? And how do you dissociate the time when a command is created and the time when a command is executed? Very typically, function calls are closest to command, but function calls have all of them integrated together. The creator is the receiver, is the delegator, and the creation of the function call and the execution of the function call happens at the same instant of time in the code. The other dimension, as you can see, is in terms of patterns which relate to class and patterns that relate to object. So majority of patterns relate to the object, but some like factory method, adapter, they are patterns on the classes, right? So this is a whole, kind of the gang of four catalog of patterns, and this kind of is an interrelationship diagram between these patterns. So these are the different relationships between them. For example, you have singleton here, and a singleton is single instance relationship with abstract factory, which kind of creates objects of variable class. Or a facade, facade needs to have one one singleton only, so it relates in that way. Similarly, what else? Iterator has a relationship from composite, from visitor. Visitor would need to iterate over the interfaces that you have, and so on. And so in this way, the command has a relationship to composite and so on. So there are, the patterns have their interrelationships between them. So when you actually become a master of all of these patterns, then you'll be considered a design guru in your company, because in any problem most often will map to one or more of these patterns. And so instead of thinking much, instead of experimenting much, you will immediately know what is the solution you should advise. Okay? So I think these details I will not go through as to what are the advantages of patterns and so on. There are certain disadvantages also. That the first thing is, do not read too much into the story. Design patterns do not directly lead to code reuse. It is design reuse. So it is still, while reusing that design, since you have a well-structured pattern there, you may adopt to good practices in your language to have a better code reuse, right? So you could, if you need singleton for all classes on a hierarchy, then you could create a singleton solution which kind of uses a template to maximize code reuse. When you are done with assignment 5, I'll show some of those examples in the solution. Some of you may have discovered it already, but keep this in mind, that design pattern or design reuse that tell you prescribed good things for recurring problems, the recurring solution and their consequences. So it helps to select the right design pattern at the right point during the design exercise. So this is, unfortunately, this last line is true, that there is no formalized methodology which can do this. This probably is a scope for deep research in AI as to, can you, in different design situations, identify the right kind of pattern. If you can, that would be great. But that so far, it is just based on the experience of the designer, of the people. Okay, so what I'll have to, we will next go into the discussing the command pattern. Before that, let me just check if there is any question. Seems to be no question, so I'll go back. So what I'll do is next here at actually, as you can see, these are slides from my last company. So there was a long discussion after this on functors. So which I will skip over because I have already told, we have already discussed what are functors, and we will go straight to discussing the command pattern. I hope the slide is visible again. Right?
Yes, sir.
Okay. So let's take a look in the world of delegation. I mean, we do that in our day-to-day life very often. How do you do that in your software design? So the command pattern is exemplified through a restaurant situation, checking at the diner situation. So it is like that the customer goes to the restaurant and places an order with the waiter. Now, the waiter writes that order on the check. I mean, a slip. Right? Then she goes to the kitchen backwards or the desk and puts up that order in the queue for the cook to prepare it. And then you are served that. So you can clearly see that what you want is in your order, right? This is what you want, right? So you are giving a command to the waiter for that order, who makes it into kind of a check, into an order, and then puts it up in a queue so that it will actually get delegated to the receiver of this command, who is the cook. The waitress does not make the food. The cook does. The chef does, right? So it goes to the cook, who actually makes the order, and the order gets completed. So that's the command scenario we are talking of. So you can now easily understand that this is a sequence diagram in a very simplified form. So you have a customer lifeline, who is a client, who places an order with the lifeline of the waitress, right? So this is where the command is being transferred to the invoker of the command, who will actually start taking actions on the command. So what does she do? She places an order, which is makes this order. This is the order check that has been produced based on your instructions. So this is the command. So command by itself now becomes an object and has a lifeline. That's where the functors come in. Right? So this is the order. The lifeline of the order is here. And then this order, I mean, it is shown in a simplified way. This order is put in a queue, and at some point it is picked up from the queue and is delegated to the receiver. Receiver is a cook who will actually place it. So it's basically you want the food, you are the consumer, and cook is the producer, but you don't go straight from customer to here. That's not the way it works. So you create a you have an interface of the waitress to create a command. The command creation is done, and then separately it is executed as and when it is appropriate, and your task is done. So this is a situation which is the situation for the command pattern. Now, if you think at this point that, I mean, isn't it too specific that we are talking about restaurants and waitresses and chefs? How recurring is it? Now, just keep remind yourself that it may be the example is from a restaurant, but this is a typical thing we do for placing any order and serving that. You are buying something on an e-commerce site, so you find out items, and then what you do, you put them in the shopping cart, right? So as you put them in the shopping cart, so here you are doing the work of the customer as well as part of the work of the waitress, which was in this order link. That is, you are noting down in your shopping cart, you are noting down, well, these are the things that I want. And then on the shopping cart, which is the waitress for you, you do a checkout. The checkout is actually creating the order, right? You do the checkout, associated payments and all that. Those details are, there are multiple other commands which come in, but you do so you're creating a command for Amazon or for Flipkart or eBay that this is what I need. So the order gets created, and that is your command, and it gets queued, right? So you get mail from that your order has been received, and you can see the status, this, that, all of these will be there. And according to the queue by the people who are responsible for preparing your shipment, they will pick it up from the queue, prepare your shipment, and this is what the cook is doing, right? There are several sub commands, delegations, entities involved, but the core of it, so this model is just taken as a minimal simplistic form of the command pattern. That is what you can happen but it keeps on happening on a very regular basis. Very different context. We are sending mails, right? So the sender composes a mail, right, with some editor like say Word or whatever, and then you press send. So you are here again doing the job of the waitress, noting down what the order is. The order is a mail, right? And once that is created, your mail is the command send, on which has to get done. So you press send, it gets queued in the outbox, and then there is a send mail thread which checks the connection and sends the mail from the outbox. So that is the cook who picks it up and does that delegated execution. So your send and actually the mail going out, the execution of the command are separated in time. They're separated in space. So that's the behavior of the command pattern. Very powerful in terms of any kind of message communicating system or a workflow system, which we'll often have. You can visualize this. We didn't get to that kind, but you could visualize this in your booking assignment also. But that's actually a booking is a request, and that is getting into a booking slip, and that gets queued for allocation, payments done, and then it gets executed. So that's so it encapsulates requests for service from an object inside other object to allow manipulation of the request in various ways. So yet another example from a GUI toolkit. We have GUI for everything. So what we have an application which has a menu. For example, say you are using Word. So the Word has a number of menu items. So those are what you actually want to do. So you can do this by the application. You can open an application, close an application, do copy paste, etc. So the menu has menu items, and every menu item has a command execute called click. Right? You do a click and then it gets executed. Right? That's same for all of these. Right? So what is important is you create a command. For example, you want to open a file. So when you want to open a file, you collect the parameters, which is in what what is the file name, the path to that file, maybe the opening mode, whether it is read only or read write, and that command is passed on to the menu, which then will pick it up and have the execute. So the command finally is execute. Right? Now the important thing here is you will have an execute as a common behavior, and you associate different functionality depending on the different commands that you can have. So you can clearly see that this is a situation for a multi-way function call branching, which is the function pointers at the lowest level, as you can see. But here is the abstraction in terms of the command pattern. So what you have a command, and then specific commands, which has an execute. Specific commands implements the functionality of that command. So you have a command, you have a paste command specialized from that, whose execute is document pointer paste, because in that document you do. But there's paste in Word, there's paste in Excel, there's paste in PowerPoint. All of these will have the same structure, while the actual document pointer paste function may be different. And then if the paste command associates with the document so that it can invoke these commands from the document. So that's the kind of separation. So this is showing for the open command. So you have the execute. The open command has an execute. It may have, this specialization may have further functionality like ask the user. For example, you are opening, so the user wants to know, the application has to know what is the name. So the ask user provides you the name, and then finally you do the same execute doc pointer open, right? So this separation is what is the important thing in the command pattern, and this is what is a general model. You have an invoker who invokes the command. That is, you get started with that command, does it on the abstraction, so that the specific command that is created, the concrete command, will delegate it to the receiver for action. And this receiver pointer action is what gets executed. This receiver knows how to execute it. The cook knows how to prepare a good samosa, right? So that's, I think I'll stop here. We will, here is the sequence. I think I'll stop here. There's not much time left to do the rest of it. In the class tomorrow, we will, I'm sorry. We will continue on this, try to show you some small examples for the command pattern, and then try to talk about some of the other patterns like visitor and, if time permits, factory. Okay. Any questions, quick questions, then I can answer.
So can you differentiate? Yeah, go ahead.
So what is the difference between command and strategy? Like they look very similar.
Command and
strategy.
Strategy pattern.
Yes, sir.
Strategy pattern is at a different level. So we will not, because to understand every pattern, you need to understand the whole situation where that pattern is relevant. So strategy pattern is at a different level. Right.
Okay, now I'm confused that the one I'm using for my term, this assignment, is strategy or command. I don't know.
Command. Strategy pattern is not easy to use, and strategy pattern is not the situations that we have here. What you are doing is you are having commands to execute, and right, and possibly you have done a little bit of deeper thinking, because even command was not required here because it's a very specific context. I mean, there's nothing wrong in using that, but here you only have a very specific context with not much of variability in that. But if you have conceived it in the way that, well, actually booking is collecting patient I'm sorry, the traveler's information, and the booking class information, and the booking category information, and then you prepare, and then I have the actual booking, which is the the command execution. If you conceive it in that way and model, that's perfectly fine. I'm sure that is what you are talking about.
Probably. Yeah.
Yeah,
That's
don't
what-
worry, don't worry. I mean, you're doing it for the first time, make mistakes, and nobody is going to, kind of put you to bars because why did you use that pattern and not this pattern? But the patterns that I'm trying to point out are which occur very frequently and at an early stage will be very useful. Then slowly we learn about the other patterns and get into those. Right? Any other
Sir,
question? Yes.
one more doubt.
Yeah.
In the two examples which were given initial, the cook one, so the order was placed to the waitress. So
Right.
there the command was built. So finally, what is the command? The waitress queuing it to the cook or the cook executing it?
No,
Like what is the
command is, if you look at this case, the command is preparing, the list. That is a command object, right?
Yes.
So that is the command.
And
Cook.
its execution?
Its execution is execution of the command. So you
which-
say that command is an abstraction which has an execute, right? Which somebody, which is a scheduler, in a generic case, which is a scheduler, will decide when to execute without knowing what that command is and how it will get executed. Scheduler does not need to know that. In a very generic context, I'm saying. But in specificity, that may be the next call in your main routine, which is actually doing the execute. Right? But the point is that you do not call the specific cook function or cook biryani function. What you call always is execute. You have a command object has an execute interface, execute. Now, depending on that command object, it will get delegated to the particular execution function. So when you prepare the command, you are preparing that command object. That is what the waitress is doing. That is what you are doing yourself when you are putting things on your shopping cart. Okay? Then when you check out is where you are creating that command, which is the order. There the command is the order, right? And then that order, there are financial compliances, but beyond that, the order gets skewed at the vendor, and some scheduler will come and execute it. Call the execute, and it will appropriately. So say think about you have ordered for a book and say a mobile phone. For both of them, it is execute. But in actuality, to execute the shipment of a book and the shipment of a mobile phone will not be the same. So that will get delegated to the execute of the receiver. Whoever is receiving it knows, the cook knows how to execute that, and it will get relegated to that. Getting it?
So basically queuing and scheduling it is a different thing.
Yes, it may be there, it may not be there. It depends on what is your temporal separation. At the end of for example, you go to say KFC or McDonald's, you will see this very clearly happening. You can see the queue on the back on the stainless steel bar. They just make all this and go and paste it one after the other, and cook is taking it from one after the other. So scheduler is there. But there are several where you have to queue up to buy something. So what it means that it is, as soon as the order is placed, it is executed. But no, two orders are not there in the queue at the same time. It depends on the policy you are following. That's a different thing.
Command, the delegation is on the executor side.
Yes, because the executor only knows how to execute. Right.
While
So a part of the command could be a kind of information on who can execute. A part of that could be, besides the parameters of the command, it could also be that who should do it. you go to the salon, and most often you will have your preferred person who attends to you. You will just not say haircut. You will say haircut to be done by Sanjay. So it is possible to be modeled that way as well. But the whole thing that you give to execution is your order, is the command. And there is a separation between when you prepare it, who prepares it and who executes it. So in
see, so
between this
command is
separation,
for-
you may have several strategies that may come in, which makes it very
That's the
generic,
strategy.
right?
I see. I now see it.
So there could also be stronger models where you may have interruptions in the execution of the command. The command goes back to the queue, and something else come in. Because in your command, a paratha has to be prepared, which some other chef does. So during that time, the main chef will not wait. He is working on the order for the other customer. So it goes to a different queue. I'm getting that. So
Yeah,
it is getting you a model to think about a command which we think as a function call, thinking of it as an object with separate invoker and executor, and allowing you a possibility of employing several strategies in between as to how you do these things.
Command is an action, or rather the not an action, like
It's an
instruction
encapsulation of what you want to get done.
Yeah, exactly.
Right.
It's the object-oriented version of an action.
Right. Okay. Okay, we are grossly over time anyway. Okay, then we will continue tomorrow morning again. Have a nice day.